Alright, so today we'll be working on differential equations, the idea of differential equations, right? To work on differential equations, as I said before, you do not need a lot of concepts of integration, right? Some basic concepts would be just fine. Okay, so we'll start with differential equations and I'll start with the very basics of it. For differential equations, we need three types of differential equations, three types of primary differential equations that we'll be dealing with. When I say differential equation, first let's come to what a differential equation looks like. So any equation that has certain components, which components that has variable x and y, and the differential components as in the equation which also has terms like dy by dx, higher order derivatives, d square y by dx square, and so on, and their product. So I'll say and their product, right? Any equation that is based on these terms is called differential equation, right? Correct? Any equation that is comprising of all these variables and their product is called differential equation. To put it simply, something that you've seen that looks like this: x square x d square y by dx square plus dy by dx plus y is equal to 0, right? Some equation of this sort, right? Or some basic equation, maybe x dy by dx minus y is equal to 0, right? Something like this. These are all differential equations. I can just put in some numbers here, that is also just fine. That would not change anything, right? So this is what a differential equation looks like. Now, when we talk about the topic differential equations for any competitive exam like CUET, what we are trying to find is we want to find the solution to the differential equation, right? So the first idea is there are multiple concepts here. So first idea is I want to understand how do I frame a differential equation. First of all, how do you frame a differential equation? And the second concept that we'll do is solving the differential equation. Solving the differential equation, right? So these are the primary things that we'll be dealing with. The primary things are we want to understand first how to frame a differential equation and then how to solve it, right? So I have come to these things one by one. Number one, framing a differential equation. Now this is a topic that is interesting, right? Framing a differential equation. How would you frame a differential equation? If I ask you, right, if I give you an example, like, can you frame a differential equation or can you create a differential equation of a family of circles with center at origin, right, and certain radius, right? What do I mean? I have given you a family of circles. What I've just said, I've given you a family of circles. I told you that the circles are centered at origin. So the circle have centers at origin and have some radius, right? Some given radius. So there is some radius which I leave for you to choose, right? Let's say I have taken the radius to be 8, right? So we want to create a differential equation under this situation. We want to create a differential equation that satisfies. So differential equation represents a lot of curves, right? So I want a differential equation that represents circles and circles with the given property that they are centered at origin, right? How do you do that? There is just one rule that you have to keep in mind when you are working on framing a differential equation, and that one basic rule is you want to, number one, get rid of all the arbitrary constant types. That means in an equation you want to get rid of all the arbitrary constants, number one, right? Getting rid of arbitrary constants. I tell you what does that mean. Can you tell me the equation of a circle centered at origin with radius 6? X square plus y square is equals to x square, right? Now the arbitrary constant here is 8, right? X and y are your variables, fixed are variables, right? The factors you need to create an equation. X and y are your variables. A is an arbitrary constant. What does this mean? If I change the value of A, I have a different equation, right? I'll have a different circle every time. But there's one fixed property, you change A, you will have a different circle every time, but that circle will always be centered at origin, right? So what we are looking here is, so it's very important that you understand this first of all. What we are looking at is a system like this. So I have a circle which is centered at origin, and let's say I have chosen some radius A1 for this, right? And then if I change the radius, I have another circle which is concentric. That means it is again centered at origin. But now the radius for the circle, as I said, I've chosen the radius to be A2, right? So similarly, I can keep changing the radius, and what I get is a circle. Right, I keep getting concentric circles. So you'll get family of circles. You're getting a lot of circles only by changing this A. Are you getting it? So this is what it means when I say I want a family of circles with one condition that the center should be at origin and the radius is A. So my arbitrary constant is A. That means A is a constant that keeps changing, and when A changes, you get a new family of circle, a new circle every time, and together we will follow a family. Okay. Alright. Now, if I want to find a differential equation that satisfies this setup, that means if I want to find a differential equation which represents all such circles, I want to get rid of this A, right? The idea is you want to get rid of your constant, but with one rule. The rule is you can do only the derivative, the order of the derivative. You know what order of derivative is? What is the order of derivative? Order of derivative is basically how many times you can do the differentiation, right? First order derivative, second order derivative. First order derivative means you differentiated your equation just once. Right? Second order derivative means you differentiated your equation twice. Right? So the order of the derivative should be equal to the number of arbitrary constants. That means, what does that mean? That simply means that whatever is the number of constants you have, you can only do differentiation that many times. Now here in this question, how many constants do I have here? 1. So how many times I can differentiate this equation? Only 1. So this is the idea. I want to get rid of A. I have to eliminate this A, but at the same time I can only differentiate 1. Is this clear to all? So for example, in this particular system, for example, if I just work on the same example that I want a differential equation that represents these circles, all of these circles. I'll just solve one question for you so you understand what I'm trying to say here. How do I get the differential equation? My differential equation, to get my differential equation, what will I do? I'll differentiate my equation. What I'll do is I'll differentiate. So I have x square plus y square is equals to a square. I'll differentiate with respect to with respect to x. Once I differentiate with respect to x, what would be the derivative? 2x plus 2y dy by dx is equals to derivative of a is b. Right? What do I have here? I have x plus y dy by dx is equals to 0. Right? This is my differential equation. Right? This is my final differential equation. Why? Because now the constants are not there. There is no constant here. My constants are reduced. I do not have any arbitrary constant here. Right? Arbitrary constants are gone, and also there was only one arbitrary constant, and I differentiated only one. Understood? Alright. Shall we try some questions based on? So next is, let's pick a question. And the question is, what if we want to find differential equation of parabolas with vertex at origin and I can say axis along the y-axis. This is the question. What is the differential equation of the parabola with vortex at origin and axis along the line. Right. First of all, let's understand what is the equation of this parabola. So what would be the equation of the parabola? This equation, the parabola, I am saying it should look like this, right? It has vortex at the origin and the axis is along y-axis. So either it is an upward parabola, right? Or it is a downward parabola. Either one of the two cases. And maybe I can add a condition, vortex at origin, axis along the x-axis, and I can say and focus at positive y-axis. That simply means I've also reduced the idea to the fact that I'm only dealing with an upward parabola here. Right? This is only an upward parabola that I'm talking about. Yes, are we all able to understand? Alright. So this is the upward parabola that I'm talking about. And I want to find equation, differential equation of family of parabolas. Family of parabola with vortex at origin, axis along the y-axis and the focus along the positive y-axis. So what is the basic equation of such a parabola? This parabola is x square is equals to 4ay, right? Which is the arbitrary constant that I have here? A. The arbitrary constant that I have here is A. That means I have only one constant. I have to eliminate that constant and I can only do the derivative once. You can only do the derivative once and you have to eliminate this constant. Right? Multiple ways to do that. Simplest, any idea that seems simple to you. Just do the derivative straight away. So you get 2x is equals to 4a dy by dx. From here, I can say, okay, I have the value of 4a as 2x upon dy by dx. And I can substitute this value in 1. So you can just substitute in 1. You will get x square is equals to 4a is 2x upon dy by dx into y, which simply just by basic shifting gives me x square dy by dx is equals to 2x. Or I can just say x square dy by dx minus 2xy is equal to 0, and this is my equation. Okay. This is a differential equation. This is the differential equation that we want to talk about. Got it? Alright. Let's look at another question. So the question I have now is the differential equation for which the differential equation for which y is equals to a cos x plus b sin x, y is equals to a cos x plus b sin x is a solution. Is a part. So we have 4 parts here. The first one is d square y by dx square plus y is 0. D square y by dx square plus y is 0. The next one we have is d square y plus dx by dx square minus y. D square y by dx square minus y is 0. Right? The next is d square y by dx square plus a plus b y is 0. And the third one is a minus b. So we have d square y by dx square plus a minus by is 0. The question says the differential equation for which this is a solution, right? Two ways of doing it. Number one, you can simply do the differentiation here, all the derivatives, substitute your values and check which solution, for which of the parts the equation satisfies one of the, the equation satisfies which one of the parts, right? Which one of the given options. One way is that. The other is you can derive your own, or you can just solve for your own differential equation, right? By eliminating a and b. The arbitrary constants here are a and b. So if you look at it, if there are two arbitrary constants, obviously your differential equation will have the order 2, right? So it will be a second order derivative involved in the differential equation. Now, one way is you can solve this and create your own differential equation. The other is you can substitute the values. You can do whatever you want. So, if I just start by solving the derivative, dy by dx is minus a sin x plus b cos x. Right, this is okay. Then I do the derivative again because I am allowed to do the derivative twice here because there are two arbitrary constants. So, if I do the derivative again, I get d square y by dx square is equals to minus a cos x minus b sin x. This is quite easy. Minus you can take common and you see you get a cos x plus b sin x. This becomes your function y itself. You get d square y by dx square is equal to minus y, or simply d square y by dx square plus y is equal to 0, which is the eighth. Alright, let's try another question. One more question, you can give a try. Okay, I'll give you a simple question. Can you find the differential equation? Find the differential equation for the family of curves given by y is equal to c1 e raised to the power x plus c2 e raised to the power minus x. C1, C2 are your two different arbitrary constants. So these options are d square y by dx square plus y is equal to 0. D square y by dx square minus y is equal to 0. D square y by dx square plus 1 is equal to 0. And d square y by dx square minus 1 is equal to 0. हो गया? What is the answer to this? B part. Let's look at it how. So my question was why c1 ex plus c2 e raised to the power minus x. dy by dx is c1 e raised to the power x minus c2, or this is c2 e raised to the power minus x. I'll do the derivative again. Then I'll have C1 EX plus C2 e raised to power minus X, which is again Y. Right? So that simply tells me the answer is D part. Understood? So one type of question is this. One type of question in the CUET paper is where you have to match your equation, differential equation with the solution. Or you're given a family and you have to match it, you have to find the differential equation corresponding to that. Just one thing you all have to understand and be very clear about is there shouldn't be any confusion around it. The curve, whatever curve you have, the curve corresponds to a differential equation, right? So I can say the differential equation represents the set of curves or the family of curves. It's the same thing if I say it basically means the exact same thing if I say this equation satisfies the differential equation, right? So even if they ask you which equation satisfies or what equation satisfies a given differential equation or something like that, all you have to do is you do the derivative, substitute in the values, and you'll be able to find it very easily, right? And for a differential equation to represent a family of curves, there's just one rule which we went over, that the number of arbitrary constants decide how many times you can do the derivative, right? If there's only one constant, you cannot create a second order differential equation, right? So for example, for a particular question, if I just go back and look at the questions we were dealing with, right? So for example, for any question like this, I had two arbitrary constants, right? So if any of the options has like maybe d cube y upon dx cube or d raised to power 4 y upon dx4, these clearly would not represent your differential equation because you had only two arbitrary constants, so your maximum derivative that you can do is 2, the second order derivative, right? That is the basic idea of differential equation representing a family of terms. Now, after this, there's one simple concept. We've understood how to create a differential equation. The idea is now how to solve a differential equation. Solving a differential equation. Right? We want to understand how do we solve a differential equation. So this is solving a differential equation. Right? Now, a differential equation can be solved by three methods. I'll just revise this with you. There were three techniques we learned through which we were solving the differential equations. Three methods थे. क्या थे? Solving a differential equation. The first method was simply the variable separable form. Right? Where you could see that you could simply separate your variables, the variable separable form. The second method was homogeneous form. And the third was it is sometimes called the direct method, or you can also think of it in terms of integrating factor. Integrating factor method. Right? So these are the three types of solutions we want to talk about. There are three ways with which you can solve a differential equation. We'll start with one method at a time. We'll pick it one by one and we'll try the questions, right? So I'll start with the variable separable form. I'll write some differentiation here so you can clearly see. Variable separable form, as the name suggests, you would be able to separate your variables. That means all the variables, similar variables, can be put on one side of the equality sign and the other variables can be put on the other side, right? That simply means all the x can be accumulated on one side, all the y's can be separated to the other side. तो तुम अपने variables को separate कर पाओगे, अलग अलग कर पाओगे. Simple example, x dy minus y dx is equal to 0. Right? This is variable separable form, right? I will be able to separate my variables. Right, I will be able to separate my two variables x and y in this equation. How? I can simply say this is x dy is equals to y dx. This is simply dy by y is equals to dx by x. Correct? I am able to separate my variables. This is variable separable. What was homogeneous form? How did we differentiate? What was the homogeneous form? What is the meaning of the word homogeneous? Homogeneous simply means similar, right? So when we talk about similarity, we want similarity in terms of degree. So similar in terms of power or degree of the equation. That simply means that you will notice that all the terms will have the same degree, right? So for example, can we pick an example here? Let's say x square plus xy, right? And I'll say, or I can just simply write it like this: x square dy plus xy dx is equal to 0, right? So you will have the similar degree, the similar power of the terms. This is homogeneous form. And then there was a direct method. Direct method had very typical formation. Right? If you remember, it was something like dy by dx plus py is equals to q, where p is a function of x and q is also a function of x. We'll look at all of this in details later. I'm just giving you an overview so that you can clearly see the difference between these forms as well. Right? Understood? Shall we move ahead? Okay. Now, we'll start with the first form, which was the variable separable form. For the variable separable form, all you have to do is just separate your variables and then integrate. Right? For example, the question that we just picked, it was x dy minus y dx is equal to 0. Right? First thing you have to notice is, are you able to separate your variables, which happens in this case. इस क्वेश्चन में हम अपने वेरिएबल्स को दोनों को सेपरेट कर पा रहे हैं. All the y can be collected on one side and the x can be collected on the other side. Needless to say, dy and dx should be in the numerator. Right? Understood? Now, once I've separated my variables, once I've come to a point where the variables are separated, I can then simply say integrate with respect to limits, whatever limits are there in the question. If not, then you can just do the indefinite integrals. So I'll integrate both sides with respect to their limits, right? This is dy by y, this is integral of dx by x. Okay, what is integral of dy by y? What is 1 by y dy integral? Log y, right? So my answer for this comes out to be, this comes out to be log y is equals to log x, and I have to obviously introduce a constant c. Constant we generally introduce when we do integration, that is obvious, that is something we know. But the type of constant you can also vary. So for example, I can see this is a log term, this is a log term. So my constant, I can also choose my constant to be represented by a log term. Instead of c, I can call it log c. Right? How would that help? That would just simplify the questions a little bit for me. I can just write this as c into x. What is the property we use here? The property we've used is from logs. The property that we've used is log m plus log n is equals to log m into n. Right? And now I can take anti-log on the both sides. So I can take, once I take anti-log on the both sides, my answer would be y is equals to, that would be my solution. Got it? Understood? Shall we try certain questions? Alright. Let's try some questions based on this idea. Oh, at the same time, this question can also be asked in a manner, so it's interesting to look at how this question can be asked. This question can be asked in the paper in a manner that, what does this question represent? So, right, if this is the equation, the question can be solution of the given differential equation represents, right, number one, a line, maybe a parabola, right? Are you getting it? C is a circle, D maybe, none. So this can be a question as well. What does the solution represent? So once you have the solution, can you judge what this solution represents? This is a line, right? This is a linear equation in x and y. This represents a line. For any value of the constant, you change the constant, you get a line, right? So this represents a line. This is one of the methods the question can be asked, right? Let's try another question. This is one question you can try this anytime. The question is, the differential equation y dy by dx. The differential equation y dy by dx plus x is equal to 0 represents first part. The first part says in which parabola, circle, and then I have hypotenuse. How do you solve it? What is the answer for this? So y dy by dx plus x is equal to 0. You can just see this is y dy by dx minus x. Y dy is equal to minus x dx. Right? Variable separate. Once you have a variable separate, you can just integrate them. When we integrate them, it will get y squared by 2 is equal to minus x squared by 2. Plus my constant, I am writing c by 2. And that simply gives me y squared plus x squared is equal to c, which is equation number 2. Okay? Understood? Alright. Once this is done, we can now move to the next idea. So this is how variable separable form goes. Right? Alright. Let's also discuss the next form, which basically is homogeneous. Homogeneous form. Homogeneous form of the sentence. There are not many questions of homogeneous form in this book. For the very basic part of it, homogeneous form, you can just start with a question that looks like this. Which of the following is a homogeneous differential? Which of the following is a homogeneous differential? The first equation, 4x plus 6y minus 5 dy by plus 3x minus 2y minus 7 dx equal to 0. Right? The second one is xy dy dx, xy dx plus x cube minus y cube dy is equal to 0. The third part is given to me as x square plus 2y square dx plus xy dy is equal to 0. The fourth part is given to me as x cube plus 2y square dx plus x square minus y square plus xy dy is equal to 0. The question said which of the following is a homogeneous differential equation. The first idea is you have to identify clearly which of the following is homogeneous, right? It's not a very tricky thing. Which do you think is a homogeneous? The second one the third one very simply, right? Right? The third is a homogeneous differential equation. How would you get the idea that this is the homogeneous differential equation? How do you check? The simplest idea is you do not have to go by, you substitute x as lambda x, you substitute y as lambda y. This is one method. You substitute x as lambda x, substitute y as lambda y, and if your equation comes out to be exactly the same what you've been dealing with earlier, so you get differential equation. Just look at the powers. Here your variable has power 1. Here your variable is power 1. Here there is no variable power 2. Different power. Wherever you have a different power, that means it's not different. Here the variable together they make power 2. One for x and one for y. Together the variable is of power 2. Here I have cube and cube. This means this is also not a. While in this case, every element will have a variable that holds power 2 together. Right? And for the fourth one, this is cubic, this is quadratic, 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 quadratic. This is not a homogeneous. The first step is you to correctly identify if this is a homogeneous. Stop with the recording. I'll get the book so that we can follow.